Now we saw, well, during the classification, we saw what is a ambiguous grammar. What is the ambiguous grammar? I'll have more than one parse tree. More than one parse tree for the same string. More than one parse tree for the same string. When it's there, then the compiler cannot decide. Okay, so the compiler cannot decide which, compiler cannot decide which parse tree to choose. Okay, so there is an ambiguity for the compiler. So we call this as ambiguous grammar. So the grammar has to be rewritten. The grammar has to be changed to reduce choices. Now the grammar has so many choices. That's why you have so many parse tree. We'll see how, what do I mean by having so many choices. The grammar has, when it has so many choices in terms of production rules, so we'll have so many parse trees generated for accepting the same input string. Okay, same string, so not accepting, for generating the same string. Okay, so one example. So while we are reducing the choices, we'll reduce the ambiguity also. So we'll first see what is ambiguity. I think I told this example yesterday. I'll repeat. So this is E minus E or A. So A is the only terminal, E is the non-terminal. A minus and plus are terminals actually. E is the only non-terminal. Okay, so my string, so this is my grammar. So this, all these examples we'll see like this. So this is a grammar. Let me see, my string is A minus A plus A. Okay, so two ways I can do it. I'll choose a leftmost or a rightmost derivation, or so E, I'll try to expand E with E plus E first, E plus E. I know plus occurs at the end, am I right? So plus occurs at the end. So what should I do after I do a E plus E? Yes, give any idea? Yeah, our string is A minus A plus A. So what should I do? I should expand this with this, and I substitute, I'm sorry, A is the only terminal, character terminal. Okay, so you get a minus A plus A. Am I right? Yes. Now I can choose the other way around. I'll choose the second option, E minus E I'll choose. So minus is in the left side. So I have to expand this with E plus E. Okay, so now we are ready. We just substituted with terminals. We get a minus A plus A. Okay, so for the same string, you can see we have two parse trees with us. Okay, so this is not correct, or this is not allowed, or it confuses the compiler. So the problem why we had like these many options for generating parse trees because of the choices. When I have start with a start symbol E, I can either expand it as E plus E, again it's a start symbol again, or I can go for E minus E, or I can directly substitute A. So I use the same non-terminal symbols again and again. Are you understanding? So E is the only non-terminal symbol that I'm using again and again. Okay, so when I do this, I have many choices. So many parse trees are generated. And in fact, do you know associativity and precedence of expressions or of operators, right? Operators in expressions, we might have studied the concept of associativity and precedence. Right. Now, plus and minus has same precedence or different precedence? Yes? Plus and minus, same precedence, or one has higher precedence compared to other? Plus and minus operator. What's the answer? Yeah.
Same.
Yeah, it's same. Plus and minus, when you see it as same precedence. So I don't have any confusion with precedence. When you have a plus and asterisk, which one has higher precedence?
Asterisk, ma'am.
Asterisk, good. Okay, so now I don't have any confusion with precedence because both the operators have same precedence. But let me come to associativity. When you see an expression like this, which operation is executed first with respect to your associativity? You might have studied something like left to right, right to left, and so on, right? So this minus is executed first or plus is executed first. Which one is correct with respect to the operators? So precedence, we said minus and plus has the same precedence, same priority level. Okay, so I cannot say which one to execute first based on precedence, same importance. Okay, associativity, in which order do I execute? Plus and minus. Is it left to right or right to left?
Left to right.
Left to right. So my execution should be like this. Okay, and this is not valid. This is incorrect and this is only correct. Okay, now I've told you while you're understanding the pass tree, you have to go from bottom to top. Now, can you tell me which? So let me consider this is a pass tree A and this is pass tree B. Can you tell me which pass tree is correct? I've given you hints. So associate precedence, no problem. Plus and minus have same precedence. Associativity is left to right is correct. Okay. And while reading, I told you the bottommost expression has to be considered first and then the top. That is how it reads the tree. Can you tell me which one is correct? Which tree is correct, A or B?
A, ma'am.
Yeah, A is correct because why A is correct? Minus comes first here and then goes in this direction. So it goes in this direction because the bottommost leaf symbols, bottommost operator is minus, right? So it first sees this and then goes here. So this is, whereas in this case, what does it do? It does a plus first. Okay, so it does a plus first and then it goes to minus. Okay, so as we saw, B tree corresponds to this associativity. So only this associativity is correct. So the compiler even should not have the option of generating these two trees. Okay, it should choose that it should generate only this tree when it has to generate this tree. So a grammar should be very clear. It should not be ambiguous like this because you give options. It is open. Like E can expand E with either E plus E or E minus E. I do not have any other non-terminals. Right. So a grammar is very vast and unrestricted. Okay. So in terms of non-terminals. So I have so many choices. So both the trees can be generated, but only one of them is valid as we can see. So such ambiguity should not be present. So your grammar should be clear so that you restrict the ambiguity. Okay, now just check if this grammar is ambiguous or not. So the grammar is S is a start symbol, AS or SA or A. And check it for the string AA. Check if it is ambiguous or not. Check if you can generate two different parse trees. Given the production rules, check if you can generate two different parse trees. So from S, I can either go for A, S. This is a valid parse tree. Another parse tree, S, I can choose S and A, and this can be represented by A. So two different parse trees for the same string using the same grammar. Okay. So this is ambiguous. Okay. Now please try doing this. S, S, epsilon. For the string, so this is a grammar. So check if it's ambiguous using the string AA, BB. In case string is not given in the exam, you choose a string and check for ambiguity. Okay. Yeah, now I'll say AA and BB. Check for the string, what all I can do. S, let me start with the first rule, A, S and B. Okay, now I'll check my string format. So A and B, you know, it starts with A and with A. Now I should see a AB here. So again, I have to choose the same rule, ASB for the string. I say A, S and a B. Now what happens? This could be replaced with epsilon. Okay, so it reads epsilon, then a B this side, then a B this side, A and A this side. So it gives a string AA, BB. Okay, fine. Now, what are the other ways of, let me start with A, S, and B. Let me try using the leftover production rule. I have not used this rule at all. Let me try using this. Try using this in place of this S. What do we get? Okay, now after A immediately, I should see a AB. So now I'll do ASB. S is replaced by epsilon. This epsilon is also replaced by epsilon. Now I get a, B, and a B. Leaving off all the epsilons, this also generates B, B. Am I right? So with epsilons, it will look like A, epsilon, B, epsilon, B. So you can leave out epsilon, so you get a, B, B. So for the same string, you have two different parse trees. So this is also ambiguous. Okay. So these are examples for ambiguous. Okay. So these are examples for ambiguous grammars. Okay. Now, you just try this one. The third example, you please try. So try, I'll give one more example. You try this later, okay? BS, AS, or epsilon. So for this, for the input string AB, please try. This is the input string. AB, please try and find if this is ambiguous or not ambiguous. Okay. We'll see more examples. Now, we'll solve this alone and we'll go for conversion. For the string AB, please try this grammar and check if you're able to generate for this string. So you know which pattern to expand. So you start with S, A, S, and a B. Okay, you want AB. Okay, so I have to replace this again. This is one way of doing it. Okay, let me say SA, S, and a B. Now what should I do? So I have got a B, then I go here and a and a B. So I don't have to expand anything further. Just I replace all, I'm sorry, non-terminals with an epsilon. So this reads like AB, and then it goes here, epsilon and a B. So I get a AB over here. Now let us try to construct another tree. Some other tree I'll construct. I'll use another order and I'll check if I'm able to get the same string. So I'll start with SA, SB. I have only one production rule. Now I'll try to use the next production rule. I'll substitute epsilon here. Okay. Then I'll expand this. Okay. SA, SB. Do you get that string? I should stop because I have only one occurrence of AB. So somewhere here I have to start replacing terminals. Okay. Now, this is the only option, right? I don't have any other production rules. Just I have to expand it further. I don't want any more A's because I just have a pair of A and B. Okay. So what do I do? This is valid. I get a AA and a BB. Right. So this generates AA, BB. So when the count of terminals is like 2 A's and 2 B's, right? So this is the only possible parse tree that could be generated. So whichever other options that I try doesn't give me any good parse tree. So I tell that this is unambiguous. So for this input string pattern that has AB and AB occurring twice, okay, so this is the only parse tree that I can generate. Okay. So with two symbols, we'll see A, S, and a B, S, and a B, and an epsilon. So generate for A, B, B, A. So here what I do, I just say A. I'll choose the first one because my string starts with A. I cannot choose this. I have to always choose this. Okay. A, S, and A. Now after A, I have to get a B. Okay. So let me choose B, S, and a B. So it is A, B, B. So I can put epsilon over here. So when I read it is A, B, B. this B and this A. So it is A, B, B, and a A when I traverse like this. Now to check the ambiguity, I'll check substituting other production rules and check if I'm able to create the same string, generate the same string A, B, B, A. Now I'll check the other rule, BSB. I can't substitute BSB because the leftmost terminal, that it becomes a terminal. Okay. When I use BSB, it becomes a terminal. So no option. I have to go with ASA. Now, can I use rule now one? Can I use A again? ASA, can I use it again? Because again, 2 consecutive A's will appear. So if I use ASA again, I'll get AA. But I don't want that pattern. Okay, so I can't substitute rule 1, no options. Can I substitute epsilon directly? If I substitute epsilon directly in place of S also, I'm going to get only AA. So that's also not allowed. So I cannot substitute both rule 1, production rule 1 and 3, I cannot use. Okay, at this stage. So I have to go for the second rule only, BSB. So in case I use a BSB, this is the only option. So no other pass trees are possible for this given input string. So it is not ambiguous. Okay, so this is how we check for ambiguity.